Good day, grade 9 science students. Today what we're learning about is atomic structure. To learn about atomic structure, I want us to know how big an atom is. How big are protons, electrons, and neutrons? To do that, we're going to look at the scale of the universe. This is an online website if you want to check it out. So what we're going to do is we're going to just zoom in, and we're going to look at it. Right now we are at human size, but as we zoom in, we're down to the size of meters. You can see we're looking at smaller and smaller things. Microwaves, coffee beans. We're still zooming in. This is the size of an ant. We can still see this. We're now down to the millimeter size. Dust mites, still can see it. Amoebas, parameciums, the human egg, we can barely see. This is the smallest thing that we can see at this point. We're zooming in even further. Still not the size of an atom. A white blood cell. A nucleus in a cell. It's not to be confused with the atomic nucleus. We got bacteria. Chromosomes. We're down to micrometers. Take a meter divided by 6 times. It's by 10 6 times. We're now at the smallest thing that you can see with a light microscope. And we have HIV, hepatitis V, viruses, finally down to the size of DNA. Still zooming in. We're now down to the size of nanometers. Take a meter divided by 10 9 times. We are now at the size of a carbon atom. And an atom is at the size of nanometers. So take a meter divided by 10 9 times. You can see water molecules. Now this is not a great demonstration because the electrons are actually much smaller. So let's see if we can get down to the size of protons and neutrons. So this is the size of a hydrogen atom. It's at 1 angstrom, we call it. Extremely small. We're going to zoom in further. We have to get down all the way to femtometers to actually look at the size of nuclei. This is the size of a uranium nucleus, a chlorine nucleus, a helium nucleus. We're going to get all the way down to protons and neutrons, which are similar sizes. Well, how big are our electrons? To find out the size of electrons, we have to zoom in way further to find the size of electrons, all the way down to the size of altometers. And right around this size is the size of an electron. It's extremely small. So the Bohr Rutherford model of the atom is a way of representing an atom on a piece of paper. It's not a good, a real representation of the size because the nucleus is really small. But it's a good representation because it shows all the protons, electrons, and neutrons. And generally what it has is it shows the nucleus, and the neutrons and the protons are going to be labeled in the nucleus, and then it shows the shells or orbits, which are the electrons. The electrons are located on the outside, and they orbit around the nucleus. This model is really based off of Bohr's planetary model of the atom, where the electrons are found in orbits around the nucleus. And we're going to talk about why this is in class, but 2 electrons fit in the first shell, and then 8 electrons fit in every other shell. Now we can draw Bohr Rutherfords up to the element calcium. Okay, so let's draw the Bohr Rutherford for for carbon. Remember that we can do up to calcium. We can't go beyond calcium. Okay, so what I want us to do is know that our periodic table is labeled by these numbers at the top. Now these are called the groups. This is the number 1 group or family. This is the number 2 group or family. We skip all the way over here. It says 13, but it also will say a number 3A above it. So this is the numbers. And these are the Roman numerals. This is for 3, 4, 5. This is for 6. This is for 7. And this is for 8. So make sure that you have those labeled on your periodic table because they're going to mean some important stuff. So later on. So we're going to do the Bohr Rutherford for carbon. So carbon has 2 numbers from the periodic table that we know about. We have the atomic number, which is 6, and we have the atomic mass number, which is 12.01. We're going to round that atomic mass number to just 12. And we can talk about why that is in class, but we round it just to 12. To find the number of protons, it's equal to 6 because it's the atomic number. The electrons is also going to be the same. And to find the neutrons, you have to subtract the two numbers. So 12 minus 6 is 6. So to draw the Bohr Rutherford, this is how we do it. We represent the nucleus just by a P and an N, because we know that protons and neutrons are in the nucleus. So we got 6 and 6. The next thing that we do is we represent the electrons. And the way we represent the electrons is by drawing shells. Now the shells are where the electrons go. Excuse me. And so we have 6 electrons to place. And what we have to remember is 2, 8, 8 for our electrons. That means the first shell holds 2 and then the next shell holds 8. So what we do is we half fill the first shell, which is with 1, and then we fill it. And electrons like to be in pairs. So the first shell holds 2, so that means it just has 1 pair. The next shell, oops, a little bit wobbly there, it's going to hold 8, okay? So half filled is 4. So we placed 2 so far, and we have 4 more to go, because 2 plus 4 is 6. So we half fill it, 1, 2, 3, 4. And this is the Bohr Rutherford for carbon. Okay, so Bohr Rutherford carbon is complete. So let's complete the Bohr Rutherford for fluorine for a little bit more practice. I'm also going to introduce something known as valence electrons for you. Okay, and also something known as the Lewis dot diagram, which will explain what it means as well. Okay, this is what we're going to do next, and then this is going to be the end of the video. Okay, so when we look at fluorine on the periodic table, we see that we have two numbers. It has 9 and 18.998. And this is in group 7, so it's got VII. And we're going to learn that it means something special about the amount of valence electrons it has. Now, you don't know what valence electrons are, but you're going to learn very shortly. Okay, so I've summarized how to do a Bohr Rutherford right above me. The steps are right here. So the first thing you want to do is find the protons, electrons, and neutrons, and then put P and N in the middle, and then place 2 electrons in the first shell, paired if you have 2 to place, and then place electrons in the next shells after that. And remember to half fill the shells and then pair always. So let's do step 1. So to find the protons, electrons, and neutrons, all we're going to do is the atomic number is 9, so therefore it's got 9 electrons. How many neutrons does it have? We just subtract the two numbers. This rounds to 19, so 19 minus 9 is 10. All I'm going to do is put my protons and my neutrons in the middle. This is step 2, and then I go 9 and 10, and now I'm going to place my electrons in the first shell. Now I have 9 electrons to place, so this definitely means I can fit 2 electrons in the first shell. 1, 2. Now, oops, that electron just jumped away there. So 1, 2. Next, what we're going to do is we're going to place 7 more electrons because I have to place 7. Now, we have to half fill before we pair. And I have 7 to place, and the shell is going to have 8 in it. That means I'm going to place it at 4 spots. Here, 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 and here. So I half fill. 1, 2, 3, 4. It is now half full. I've got 6 electrons to place. I have to place 3 more to make 9. So 7, 8, 9. Okay, so that's the Bohr Rutherford for our diagram here for fluorine. Now, what are valence electrons? Well, valence electrons are the electrons in the outermost shell. So valence electrons, and I'm going to use E negative to represent electrons, are electrons with E negative in the outermost shell. Okay? And so what we're going to say is, how many valence electrons does this have? Well, the answer is 7. In this case, there's 7 valence electrons. And if we look back at the periodic table, what group was it in? It was in group 7. Okay? To make a Lewis dot diagram, all it is the electrons in the outermost shell. And how many electrons does it have in its outermost shell? 7. So to draw a Lewis dot diagram, all you have to do is show the element symbol, which in this case is F, and then just show the valence electrons around it. And the valence electrons, it's got 7 of them, we draw it exactly what it looks like on our Bohr Rutherford, the outermost shell. We don't show the inner shell, just the outer shell. 7 valence electrons, that's it for today's lesson. Try one more, a few examples here. I'm going to give you some examples tomorrow in class and also on this video to try, and hopefully it works well. Thank you very much. Bye.